Somewhere on the sun-scorched islands of eastern Indonesia, a farmer wakes before dawn and does something that would seem unthinkable to most people on Earth. Before checking on his family, before making tea, before doing anything else, he walks the perimeter of his property looking for tracks. Not the tracks of thieves or wild dogs, but the heavy, dragging footprints of a creature that has walked this earth for millions of years. A creature that can grow longer than a pickup truck, sprint faster than a human being, and bring down a deer with a single swipe of its muscular tail. He is checking for Komodo dragons, and if he finds fresh signs, he knows the day ahead will be anything but ordinary. This is daily life for thousands of people living on and around the islands of Komodo, Rinca, Flores, and Gilimatang in Indonesia. These communities share their land with the world's largest living lizard, a predator so formidable that scientists once struggled to explain how something so powerful could still exist in the modern world. For generations, people and dragons maintained an uneasy truce, each respecting the other's space. But in recent decades, that fragile balance has been fracturing, and the consequences have been severe. Livestock vanish in the night. Children are warned never to walk alone near the forest edge, and government officials find themselves caught between protecting an endangered species and protecting the people who live alongside it. What makes this story truly remarkable, however, is not just the threat itself, but the extraordinary solution that Indonesian communities and researchers began experimenting with to counter it. A solution that did not involve guns, fences, or government-funded relocation programs. Instead, it involved one of nature's most underestimated animals, the humble, spiky, seemingly slow-moving porcupine. What unfolded after that decision was made surprised nearly everyone involved, and it offers one of the most fascinating case studies in modern human-wildlife conflict management. To understand why such an unconventional solution was even considered, you first need to appreciate the scale of the problem that Komodo dragons create when they move into human territory. These are not shy, retreating animals. Komodo dragons, scientifically known as Varanus komodoensis, are apex predators in every sense of the phrase. An adult male can reach 3 meters in length and weigh over 70 kilograms. They possess serrated teeth capable of tearing through flesh and bone, powerful claws built for digging and gripping, and a deeply forked tongue that samples the air constantly, detecting the scent of prey from distances of up to 9 kilometers. For most of their evolutionary history, Komodo dragons preyed primarily on deer, wild boar, and smaller mammals that populated their island habitats. But as human settlement expanded across the Lesser Sunda Islands, natural prey populations declined. Forests were cleared for agriculture. Wild boar were hunted. Deer retreated to shrinking patches of wilderness. And Komodo dragons, being the supremely adaptable hunters that they are, began looking elsewhere for food. What they found near the edges of human villages was, from a predator's perspective, extraordinarily convenient. Goats, chickens, and pigs penned in enclosures, slow-moving and unable to escape. The dragons learned quickly, and they kept coming back. Livestock losses devastated rural families, who depended entirely on their animals for income and food. A single goat represented days or weeks of earnings for many households. When dragons struck repeatedly, the economic damage compounded into something genuinely crushing. Families fell into debt. Children missed school because parents could not afford basic supplies. The psychological toll was equally significant, with surveys of affected communities revealing that the majority of residents lived in a persistent state of fear and anxiety, altering their daily routines, restricting their movements, and sleeping poorly out of worry about what the darkness outside might bring. What complicated everything further was that Komodo dragons are strictly protected under Indonesian law and listed as a vulnerable species by the International Union for Conservation of Nature. Killing or capturing them carries serious legal penalties. This placed affected communities in an impossible position, living with a genuine threat they were legally prohibited from removing. Officials needed solutions that were both effective and compliant with conservation obligations, and the options on the table ranged from electric fencing to ranger patrols to community education programs. None of them, however, were as strange or as intriguing as what one group of researchers and community leaders began exploring on the edges of dragon territory. The Sunda porcupine, known scientifically as Hystrix javanica, is not an animal that typically commands much attention. It is nocturnal, reclusive, and spends most of its life underground in elaborate burrow systems dug into hillsides and forest floors. It does not roar, does not charge, and poses no threat to humans whatsoever. But it possesses something that has made it one of the most reliably defended animals on the planet. Approximately 30,000 hollow, barbed quills covering most of its body, each one capable of detaching on contact and embedding itself deep into the flesh of any attacker unfortunate enough to get close. The quills of a Sunda porcupine are not merely sharp. They are engineered by millions of years of evolution to cause maximum damage upon entry and maximum difficulty upon removal. The microscopic barbs that line each quill work like fishhooks inside flesh, resisting withdrawal and working deeper with every movement of the victim's muscles. An animal that attacks a porcupine and receives a face full of these quills does not simply shake them off and try again. It endures swelling, infection, and in severe cases, internal organ damage if quills migrate inward. The lesson, once learned, is rarely forgotten. Ecologists studying predator-prey dynamics in Southeast Asia had long noted that Sunda porcupines seem to exert a disproportionate influence on predator behavior relative to their size. Larger carnivores, including pythons, clouded leopards, and Javan leopards, had been observed actively avoiding areas where porcupine populations were dense, even when those areas offered plentiful alternative prey. The porcupine did not need to fight every battle. Its reputation preceded it, and that reputation alone reshaped the movements of animals far more powerful than itself. When community leaders and wildlife researchers in dragon-affected areas began discussing this phenomenon, an idea took shape that was simultaneously obvious and audacious. Komodo dragons were known to rely heavily on burrows, not ones they dug themselves, but burrows created by other animals, which the dragons appropriated for shelter from the intense tropical heat and as temporary ambush positions. If porcupines could be established in key areas around villages, they would claim those burrows, defend them aggressively, and potentially create zones that Komodo dragons would learn to avoid altogether. The island of Java, where Sunda porcupines are native and relatively abundant, lay within accessible distance by boat. A translocation program seemed feasible, and so it began. The initial results were, by several accounts, genuinely encouraging. Porcupines transported to dragon-affected areas on Flores began establishing burrows within weeks of release. They are adaptable animals, and the terrain and vegetation of Flores suited them reasonably well. As their populations began to take hold, researchers and local observers noticed something striking. Komodo dragon activity in zones where porcupines had settled appeared to decrease measurably. Dragons were being spotted less frequently in those specific areas, and some of the boldly habituated individuals that had previously made almost daily appearances near the village perimeter seemed to be redirecting their movements. Several direct confrontations between the two species were documented, and they confirmed what the theory had predicted. When Komodo dragons encountered porcupines and attempted to investigate or attack them, the outcomes were consistently damaging for the dragon. One adult male dragon was observed approaching a burrow entrance and recoiling sharply after a porcupine inside the burrow raked its snout with a defensive thrust of quills. Rangers who later examined the dragon at closer range noted visible puncture wounds around its muzzle that had become inflamed. Dragons, which depend on their sensitive tongues and facial tissues for hunting and navigation, are particularly vulnerable to precisely this kind of injury. The behavioral learning effect appeared rapidly. Dragons that had encountered porcupines began showing avoidance behaviors around burrow clusters, making wider detours around areas where porcupine activity was visible. This was not entirely surprising to researchers familiar with how predator cognition works. Komodo dragons, despite their reptilian classification, are far more intelligent than popular perception suggests. Studies have documented their capacity for individual learning, spatial memory, and behavioral adaptation. Once a dragon associated a particular zone with painful injury, it adjusted its patrol routes accordingly. But this is where the story takes its unexpected turn, because the porcupine strategy, while genuinely effective in certain respects, generated a set of consequences that nobody had fully anticipated, And some of those consequences created new complications at least as challenging as the original problem. The first unexpected development was agricultural damage. Porcupines, as herbivores, feed on roots, tubers, tree bark, and crops. As the translocated populations grew and spread beyond their initial release zones, they began finding their way into farmland. Sweet potato fields, cassava plots, and fruit orchards suffered significant damage in areas where porcupine numbers increased rapidly without the natural predator pressure that would have controlled them in their native Java habitat. Farmers who had agreed to the porcupine program to protect their livestock now found themselves losing portions of their crops to the very animals that were supposed to be helping them. The irony was not lost on anyone involved. The second complication was subtler, but arguably more significant from a wildlife management perspective. Komodo dragons, rather than simply abandoning dragon-affected zones entirely, began adapting their behavior in ways that made them harder to track and manage. Some individuals shifted toward more nocturnal activity patterns, exploiting the hours when porcupines were least active and when human monitoring was most limited. Others moved to areas where porcupine coverage was thin or non-existent, which, in some cases, meant pushing toward village edges that had previously experienced fewer dragon encounters. The deterrent had not eliminated the threat so much as it had redirected and redistributed it, creating new pressure points in areas that were unprepared. Wildlife researchers observing these behavioral shifts noted that Komodo dragons were demonstrating exactly the kind of cognitive flexibility that makes managing large predators so difficult. These animals did not simply accept the new reality that porcupines had created. They interrogated it, tested its edges, and found workarounds. One particularly bold male dragon in a study area on Flores was documented making repeated nighttime incursions into a zone it had avoided during the day following porcupine establishment there. The dragon had not been deterred. It had merely adjusted its schedule. What the porcupine experiment ultimately revealed was not a failure of the idea itself, but rather the profound complexity of the ecosystem within which that idea was being applied. The concept of using one native species as a biological deterrent against another is sound in principle. Nature does this constantly, and the research literature on predator-prey dynamics supports the notion that porcupines can meaningfully influence the spatial behavior of larger predators. The problem is that ecosystems are not controlled laboratory environments. They are dense, interlocking networks of species and behaviors, and introducing a significant change into one part of that network sends ripples through every other part. What communities in dragon territory have learned through this experiment, and through decades of living with this challenge, is that no single solution addresses the full problem. The porcupine strategy works better when combined with reinforced livestock enclosures that remove easy food opportunities. It works better when paired with community education programs that teach people how to recognize and respond to dragon behavior safely. It works better when healthy prey populations, deer and boar, are maintained within dragon territory so that the reptiles have less incentive to seek alternative food sources near human settlements. And it works better when local knowledge is incorporated into the design from the beginning, because the people who live with these animals every day understand their patterns in ways that outside researchers simply cannot replicate from field notes. The story of Indonesia's porcupine experiment is ultimately a story about the difficulty and the necessity of creative thinking in conservation. It is a story about what happens when human communities are forced to solve genuinely hard problems with limited resources, deep cultural stakes, and a legal framework that constrains their options in ways that outsiders rarely appreciate. The porcupines did not slay the dragons, but they did something perhaps more valuable. They revealed the contours of a problem more clearly, and they demonstrated that biological, community-based, and culturally sensitive approaches deserve serious investment and careful study. The Komodo dragon will not disappear from these islands, and neither will the people who have called them home for generations. The question is not whether they can coexist, but how. And the answer, as the porcupine experiment showed, lies not in any single clever solution, but in the patient, adaptive, deeply human work of learning to live alongside the wild world we share.